Now, this is great. It's pretty powerful syntax, but what if I have let's say I am a used auto dealer and I have 200 cars on the lot. This syntax here does not allow me to add and remove cars without changing the code of my application. Now, I can't go in and change the code of my application every time I want to add and remove a car from my car lot. That's ridiculous. That would be a terrible program. So I have to figure out a different way to make this data flexible. And that is where lists of classes come in really handy. Now you remember, lists can have anything. So a list or any kind of data structure, including a dictionary, can have classes held in it, which means I can add and remove those classes from that list on the fly. So if I'm a used car salesman and I have 200 cars on there and I have a program that manages that inventory, then I can store data about each car as its own object, and it will allow me to add a car, remove a car, that sort of thing. So let's take this code and we'll convert it really quick to a list-based code. Okay, so the first thing I need to hard code is the blank list. I'll call it li cars. And then instead of assigning this to a variable, I'm going to append each one of these instances to a list. So I'm going to go li cars dot append, and then I'm going to put that in there. Okay, so there we go. So now I can't refer to these as my car 1, my car 2, my car 3, but what I can do is this if I want to. And these objects still function the same way, right? They're just inside a list now. So I can refer to them by their index. And you'll see if I run this code, works exactly the same way it did. And that's kind of cool.